So in the indexing, to index a collection using Lucene, what we have to do is we have to somehow write or basically parse the data based on its data type. If it is an HTML file, we need to write or we need to utilize some form of HTML parser to parse the data out of it. If it is, say, an XLS file, we need to write the corresponding parser for that, or Word or PDF or any TXT or any other file. If the data, based on the data type, we need to write the corresponding code to extract the information out of it. Okay. Now this part will be essentially taken care of by the Lucene. And this part, we need to write the corresponding code, and we need to parse the parsed data first into the analyzer, which will be basically responsible for the pre-processing. Pre-processing in the sense the stop word removal, if we want to do that, and stemming. Stop word removal and stemming altogether is referred to as stop stem. So these steps, along with lowercasing and all that we have done using NLTK manually, those will also be taken care of by the analyzer module defined in Lucene. And based on the data, based on the parsed data, we will be creating the index. Okay. Now the collection, so these are the individual collections, right? So this is a collection, and so on. This individual, so these are basically the collection of data. In other word or more formal word, which are also referred to as corpus. Sorry. Corpus, plural is corpora. So essentially, this corpus or these collections can be different things, right? So for example, it can be a set of documents, basically a set of academic papers. It can also be, in that case, the document, the individual document will be basically a set of fields containing the different section of a paper. I hope you have seen some academic papers where we have the title at the top. Here we have the title, then we have the author name, and so on. Then if it is, then it's usually it's abstract, then introduction, and then different other fields. So based on the fields, the document will be basically consisting of individual fields. So a single document will be consisting of, say, multiple fields. For example, title, say, relevance-based language model, the title of the paper. Author, say, Victor Lavrenko, and so on and so forth. Publication venue also can be a field. The most robust field or most word-heavy field will be basically the entire content. Abstract will be just the abstract of the paper, and there can be introduction, as I have said. There can be related work, and so on. There are multiple fields that we can consider. Or what we can do is, other than the abstract, we can consider the entire rest of the content as the content, let's say. We can also do that. Now, considering our data set, the collection is basically a set of movie information, where the individual documents consisting of different fields, basically a set of fields containing different information on the particular movie. For example, the title can be a field together with the release date, origin, and so on and so forth. In the assignment, I have told you to consider only this plot, which is basically a very brief introduction or very brief summary of the plot of this movie having this title. Now, to index a collection, basically a set of documents, or other word called corpus. The input will be this set of documents and the output will be a corresponding index built using PyLucene or Lucene, uh, using those documents, using those content of those documents. Now, in order to use the Lucene, the necessary packages that we will be using from the Python wrapper, which is PyLucene, are very broadly these. First of all, we need to import the Lucene. Then these are some of the classes, basically some of the classes defined in this package, which we will be using to make the index using PyLucene or the Python wrapper of the Lucene. Okay. Now you can understand that the analysis part, that is the pre-processing part, is dependent on the language that we are considering, together with the stopword that we are using. And essentially this stopword or stopword list is dependent on the language. Do you know why? Because in some languages a word can be a meaningful word, in other languages the same word can be a stopword. For example, die. We know this should not be a stopword in English, but in German this means the, which is essentially a stopword. So this stopword is actually dependent on the language that we are using. So based on the language of the document, we should be setting the corresponding analyzer, which is basically the responsible module to process the content. Okay. Now we will be writing the codes using these. Now to start the PyLucene, the first operation that we should be doing is initializing the virtual machine. As I have said, this Lucene is basically written in Java, and we will be using this JCC, which is basically a C++ compiler, to basically use those Python libraries from the Python wrapper. Use those Java libraries from this Python wrapper. So to initiate, so basically what this will be doing is it will be creating a virtual machine where the Java packages will be available, and through the calling of the function calls using Python, we will be basically interacting with this virtual machine. So the first operation we should be doing is initiate the virtual machine. All right, let's look at some examples. So this was the assignment that we have written in the last class. Okay. So to access, so first of all, so first just initiate this Lucene and initiate this virtual machine. If I execute this cell, you will be seeing one output such as this: JCC environment at this location. So this is the memory location where this virtual memory is initialized. Now I will be showing you certain, differentiating different analyzer. It can be an English analyzer. There can be multiple analyzers also depending on the language. For example, if we have the test data like this is how we do it. If we use a standard analyzer, we will be getting some result, and if we use an English analyzer, we will be getting some other result. So for example, let's look at this. Let's consider the test data as the quick brown fox jumped over the lazy dog. We can understand that this is an English text, right? Now, considering this English text, an obvious choice is to use the English analyzer. Note that this English analyzer is defined inside this package org apache lucene.analysis.en. Then this English analyzer is defined. Again, note that this is defined or this is written in Java, not in Python. Unlike other packages or other imports that we have done, where all these packages and modules are written using Python, here it is an exception. All these imports, all these operations are written in Java. How we will be basically interacting with that is basically through this virtual machine. Now let's look at the different outputs that we will be getting. Using English analyzer, if I execute it, you will be seeing the is removed, the quick brown fox. So let me just print the raw data together with that. So print raw data. The raw data was the quick brown fox jumped over the lazy dog. You can see the removed, quick brown fox jumped has become jump by the stemmer. Over is still there. The is again removed. Lazy has been stemmed into lazy. Now this is something that I think you are encountering for the first time. From the stemming examples that we have seen so far, it's something, I mean, we might be having the impression that it is something using which it will be, I mean, we will be basically, I mean, the operation that it will be doing is basically stripping some parts from the letter, I mean, from the suffix of the, basically that word, right? But here, we are not actually stemming I mean, any letters are not actually stripped. What it is actually doing is basically making this Y to I. Now, this is the way this porter stemmer, which is by default for this English analyzer, which is defined inside. The rule-based stemmer, which is porter, the rules are if a word having 4 or more letters, the last letter is Y, then we should be, I mean, the stemmer should be converting the last word into I. So this is the way the porter stemmer has been defined. Note another thing, dog, the last word was dog, then full stop, but here that full stop is also removed. Okay, so this is the output of the English analyzer. English analyzer. Now there is another analyzer called white space analyzer. Okay, first let's see how it is actually working. So I'm defining an object of the English analyzer which is imported here. And then, as I said, the entire string will be considered as a stream of data. Now, this token stream function is defined inside this English analyzer module or function, which is taking two parameters. One is the first parameter is a field parameter, which we will be discussing later on. For the time being, I'm just keeping it empty because I'm not actually storing it somewhere. So that's why I'm keeping it as empty field, just an empty, not empty field, but just an empty string. Then the second is string reader, which is basically converting this text, which was str in Java, in Python, into a Java string reader, which is basically a package defined in Java. Okay, you can see java.io string reader. Okay, so note that all the functions we have seen so far, or all the modules that we have seen so far, all of them are basically written in Java. Everything is written in Java, unlike the situation that we have seen so far. Okay, seen so far in this Python, because every time we have imported something, the something has been defined in Python, but here it is different. So yes, so what we are doing is I'm converting this string reader, basically this text, into a stream, and then this is the general way of starting the stream reset. And then what I'm doing is I'm basically incrementing individual tokens and appending it into a list. Okay, so this is the syntax, and same syntax is repeated for the other, except I am initializing the analyzer with a different analyzer module. Here the module name is basically white space analyzer. Let me just write it here as well. Now, if I execute it, you can see the white space analyzer, the output is the is kept as it is, quick. So basically, on presence of the white spaces, they are basically stripped. Note that this full stop is still there. So from the name, I hope you can understand it is stripping based on the presence of the white space. Another very popular analyzer is simple analyzer. Let's see what the output would look like. Simple analyzer is basically just converting them into lowercase and excluding or removing the special characters. Note that they are not being stemmed in case of both white space analyzer as well as simple analyzer. So now we have seen up to this 3 different analyzer: English analyzer, white space analyzer, and simple analyzer. Now, based on the requirement, we will be applying some of these analyzer accordingly. Now, so far, as we have said, in English analyzer, there is a stop word removal which is happening. Now, an obvious question that you might be having is, which words are considered as a stop words? Can I provide a list of stop words by myself? The answer is yes. We can actually do that. As we have seen in a data set such as this Wikipedia plot data set, we can realize that the word movie is actually a very uninformative term. In that case, we should be using it or considering it as a stop word. But as we have seen, as we can understand, it is not a general stop word in the English stop word list. So one way of having a stop word list initialized by the user, by the programmer, is using stop analyzer. So here I will be discussing this later, but let me just show you what will be, how we will be using this. So one obvious thing is this stop analyzer, we will not be able to call it like this. Why? Because we need to initialize a set of keywords or set of words as a stop words as a parameter here. So if I execute this, you'll be seeing that there is an error, invalid args error. So you can see in 38th line, which is this 38. Here it is expecting one parameter, which is basically we should be providing with a set of words which we should be considering as the stop words. Now we will be redoing this, revisiting this later on. Okay, how to actually do this. Okay, moving ahead. Now the indexing is consisting of 2 major parts. First is analyzing, then writing the index. To analyze, we have seen we should be using some of the analyzers using syntax like this. The second part is, after analyzing the data, write the index or make the actual index. To do that, the defined module or defined function is called index writer. Okay. Another thing regarding analyzer is we can have a different languaged analyzer as well. For example, we can have a German analyzer, we can have a Bengali analyzer or a Hindi analyzer as well, which are already defined in this Lucene package. So this is the example that we have seen. Mostly, we will be concentrating on, or we will be mostly using the English analyzer for handling the Wikipedia plot dataset that we have used for the assignment 1. Now, to make the index or to use the index writer to actually write the index in the in the directory, we will be using certain procedure. Now, first of all, we should be, so this is this index writer function, or index writer, basically this is a module, is defined inside this package. Again, all these are written in Java. Note that. Together with that, there is another module called index writer config, which we should also be initializing. And based on the place where we want to store the data, that is, if we want to store it in the hard disk, whether in the hard disk or in the RAM, of course, we can understand that this will be volatile and this will be non-volatile. We can actually specify them using this statement. So here, this is the basically this is the module, or this is the package you can consider from the terminology of Python, where these different directory handlers are written. Here, simple fs directory is basically considering it as a file system directory. It can be a RAM directory as well, in which case the inverted index or the index will be created in the RAM. Essentially, as we can understand, we will be using this fs directory. Again, revisiting what I have said, we will be considering the hard disk to store the index in our system. And for doing that, we will be using this fs directory package or fs directory module. Now, the first thing is we need to initialize the index path. This is basically a variable. Don't go into the, this is, if you want to name it otherwise, you can name it otherwise. This is a package which is defined inside here, java.io. Here, this is the parameter, which is basically the path where we want to store the index in the hard disk. So it will be basically a path in your hard disk. And then this statement will be making the corresponding path, the path we are specifying here, to be used for storing the index. Okay. And then we will be initializing an index writer configuration, which will be initialized with the analyzer. Note that unlike the other cases, the earlier cases, where we were using this analyzer separately, here we will not be using them separately. Here, the beauty of this index writer config is, if we provide a raw data, to be stored, to be indexed, if I use this statement, by default, the data will be analyzed using this analyzer. We need not do that explicitly by these statements or the statements that we have written here. But this is basically, how we can do that manually. This is a way that I have stated. Okay, so indexing, the first part is we definitely need to parse the data, and based on the data type, we will be using the corresponding parser, whether it is already available or it is written by us. Based on that, it's just a simple step. we need to use the appropriate parser. In our case, for the Wikipedia movie dataset, plot summary dataset, it is a CSV file, as we have seen. So for that, we have actually processed, or we have actually parsed it using two different packages. One is using the CSV and another using pandas. So as we have said, using pandas, it's much more robust, because considering the first line containing the actual row, the column information like title, then the release year, and then so on and so forth up to the last column containing the plot, and these information, these names are actually present in the file. If we use the CSV package, then we need to exclude them from being basically considered. But in case of pandas, they will be basically considered as the column, basically the index of a list, or particularly speaking, it is basically will be considered, these names will be considered as the indices for the data frames, right? So one way is using the CSV and another way is using the pandas. And here we have said that we will be considering this plot information to make the data set, isn't it? So what we need to do is, for each document in the collection, we need to, of course, import certain packages or certain modules, and we need to make a document of type or document of Lucene's understandable format based on the data that we want to store, or based on the data that we want to index. Now, this is just the basic way of writing the code. I will be sharing this script at this this slide together with you as well, so that you can just consider this as a reference. But just let's try to write the code on our own. So first of all, I have initialized. So basically, this is the path where the file is stored. Let me just execute it. You can see it is executed. I'm executing this as well. So the target of my program is to index the plot field, which is stored in this file, right? Let me just write it below here. So now note that the virtual machine has been initialized. Okay. Now the first, we need to initialize this java.io, this file package. So from java.io import file, it will be needed actually. Why it will be needed? As I have said, it will be basically needed to set up the file directory where we will be storing the index. As I have said, we will be storing the index in the hard disk. So we need to specify the path of the hard disk, right? So say index path, this is the name of the variable. Then file, we will be passing the path name. Let's say so the present working directory is this. So let's say I want to store the index here. So if I provide a path like this here, it will be considering this. After this, inside this present working directory, a new directory will be created having the name index, and the index will be created in this field. Now we need to convert it into a path variable as well. Okay, now the path is set. Now we need to do another thing. We need to set up the directory as well, that is whether we want to store it in the RAM or the file system. So in this case, it is basically a file system. So what we need to do is we need to call fs directory, then open, which is basically a function defined in this fs directory module. and then we need to provide this index path that we have initialized in the previous cell here. Okay, now the path, which is basically, as you can see, there is a new file already created using this statement, which is empty at present. Okay, now let's move on. The next thing that we want to do is, as I have said, we need to set the index writer config. So let's write it with, say, writer config equals to index writer config, and I will be using the English analyzer here. Okay, because it's English data. Okay, but note that this will be basically removing the stop words. But in the assignment, it was said that keep the stop words. How to do that? I'll be discussing that later as well. So this is a basic way. Here in the English analyzer, we'll be removing the stop words as well. And then what we need to do is we need to set up another module or another object that is of the most important module here, index writer, which will be basically responsible for writing the index, writing the document, the Lucene document into this directory. Index writer, and then inside that we should be providing two parameters. First is this index dir, and the second is this writer config. Oops. Oh, okay. I have made some, yeah, it's writer config. Sorry for that. Yeah, you can see it is executed. Now let's define a function, say def index a single document. I'm just naming the function, or single plot, index single plot, where we will be providing we'll be providing certain parameters. Let's say I'll be providing the title and the plot of the movie. Note that earlier the program that we have written, we have only considered the plot, because in the inverted index there was only provision to store only one field. There was no as such provision to store multiple fields. We can actually do that using different inverted indices for individual fields, but here it is by default we can actually do that. Let's see how we will be doing that. Now, first of all, we will be declaring one document of Lucene type variable or object, which will be basically storing the individual components of the data in the Lucene understable format. Now, note that this document is defined here, which is defined inside this, which is imported from here. Okay. Now the second thing is, so note that again I'm repeating, in this function I'm passing two parameters. One is the title, the raw title. Note that the raw title and the raw plot. Raw means the raw data, the unprocessed data. The processing will be implicitly done when we will be writing the document inside this writer module or writer object. What we will be doing is next add will be adding different fields inside this Lucene document. Note that this is the Lucene document, Lucene understandable document, which is defined here. I have initialized one object here. Now I will be, for each of the field, I will be calling this doc.add function. And inside I will be providing the field, document.field, field, and then I should be providing mostly 3 parameters. There can be 5 parameters as well. Let's start with the 3 parameter declaration of field. So what are these 3 parameters? The first one is the name of the field, which will be provided as a string. So let's say title. The next is the actual thing that we want to store. Here in this case, I want to store this title, right? title. Note that this is a string. This will be the name in the index. So just to avoid the confusion, let's call it say title in all capital. And this is the parsed string, which is basically containing the title of the movie. And the third is basically whether we want to store the data, store the information in this field or not. So what is storing, we will be discussing that later. For the time being, just follow the syntax. I will be basically playing with, we will be actually basically playing with this third field, which is an important field, which will be used for later part of the course as well, particularly during the feedback. So what we'll be doing is type store. So without going into the details, what this is doing is basically I'm telling the interpreter to store the content in this variable in a field named as title, and the content will be stored. So similar to that, I will be storing the plots as well. So this is the name of the field. I can name it anything, A, B, C, X, Y, Z. I can name it anything. It's just a simple string, as you can understand. Here it will be plot. Okay. Now what we need to do is to call the add document function defined in this writer module or writer object. Writer dot add document, where we will be providing this document that we have made. Now let's revisit this function. Here what I am doing, I am passing two strings. Okay, here I am providing the title and the plot, which are basically two variables. I am initializing a Lucene document. This is basically a Lucene document. As I have said, it will be basically converting the text here into a Lucene understandable document. Basically, this document will be consisting of multiple fields. Here we have added two fields. The name of the first field is title, the name of the second field is plot, and we have stored the corresponding title and plot that we have provided as a parameter to this function. Okay, and finally we are writing that Lucene understandable document into the actual directory that we have set earlier using this writer. Okay, let's just execute it. It's executed. So I am leaving this cell out for some reason. Let's just start from here. Okay, so now what we need to do is we need to make we need to basically process this this data that we have basically that I think we have done here. So I will be just copying the code to which is basically processing the inverted index from here. So I'm just copying these 3 lines of code. So make inverted index, the file path is provided. Here it is being transformed into the basically the data frames, and then let's do it in a more formal way. So let's declare a doc ID similar to the earlier case, so that we can keep track of how many documents are being indexed so far. So for say I in say the tf.index, I hope you understand that using this we can actually access the individual documents there. Let's just try that. Actually, if we do this data frame in third bracket, say title with capital T. So this is basically the syntax of pandas. If I execute this and if I call this make inverted index function with the file path that we have set, we will be getting the individual titles. So this is basically the syntax of the pandas. Now what we will be doing is we will be basically passing the title and the plot into this single index single plot function. So we will be calling that index single plot, or let's call it single movie. It looks, it hears much more formal. Index single movie, and we will be passing two parameters, basically the title and the plot. Okay, and so let's print the file name as well, like how many documents are indexed. So for doing that, we will be just printing the doc ID here, doc ID, and then okay. So let's just execute it and let's just compile it. Now note how much time is it taking. Oh, another thing is we need to increment the doc ID here. Otherwise it will be remaining 0 as always. So so this is just for here, this doc ID is just to show the programmer how many documents are actually processed, indexed. Now, again, considering the earlier program, where we have seen that it was taking around 20 minutes at least to index, let's just call this. Let's just call this and let's see how much time does it take. So you can see already 6,000, 8,000 document has already been indexed. It was containing, I think, 24,000 document movies. So it's still running. Already 34,000, I think, the total number. Already more than half is done. And it's still running. 31,000 done. And I guess it will be done. Yeah. So the indexing has been completed. So as we have said, this is expected to be writing the index in the path that we have provided here, which is basically here, right? As you can see, some files has been created as well. Okay, so this is how we will be using Lucene to index a file, index a document or a collection, but we are not done yet. One very important factor or important thing is needed to be done, which is basically closing the index writer. So let's declare another function, let's say close writer, where we will be basically calling this writer.close. This is important. Now we need to just call this close writer function. Sorry. Close writer, and now it is closed. Now the indexing has been completed. Now let's check how large the index is. It is around 70 MB of the similar size. So there are ways to actually reduce the size as well. Now let's, for the time being, let's try to actually try to look at the index, how it looks like. Let's try to do that. Sorry, I'm actually can't find where I have stored the look. So there is actually a module called look. So this is the source, but there's supposed to be IJKL. Oops. So look. Oops, sorry. So okay. So in the next class, we are already running short of time here. So in the next class, we'll be starting with how this index is actually look like, how the index that we have created here, how it looks like. We will be, so you can see all these documents are binary. So you can see we will not be, if I double click, you can see it's kind of opening with some weird extension. All of them are binary files. So we cannot actually look them just by opening the file. So we need to have certain particular mechanism which will be basically able to read the documents that we have initialized here, which basically understands the way these Lucene documents are created. So the most important things are done here. Here we are initializing a Lucene document, we are adding two fields, and we are adding that particularly built document inside this writer, inside this Lucene index path. Okay, so I hope you can understand the power of this Lucene. A simple program that we have written, which was taking at least 20 minutes, now using this, it is able to index the same collection within a minute. That's it. Any question for until today's class?